Let's try solving some linear programming problems using Excel. I'm going to lay things out a little bit differently than the video you've seen before. So for this problem, maximize 2x plus 5y, I'm going to start off by writing out my decision variables. And I need to distinguish between what is the name of those variables. I've got x and y, and the values of them. I'm going to assume that they take on initial values of 0 just to get something in the spreadsheet. And Excel is going to find the values that should go in these cells that are going to maximize my objective function, 2x plus 5y. So let's write in my objective function, or let's go ahead and say that we want to maximize something. It is going to be 2 times whatever my x variable is, and 5 plus 5 times whatever my y is. So let's evaluate it in this cell. If I wanted to evaluate the objective function, maximize 2x plus 5y, I could say 2 times x plus 5 times y. But the reason I've laid things out this way is so that I can just use our SUMPRODUCT function, which you've seen before, sum the product of those values and these values. And what that does is takes the pairwise product, this value gets paired with that value, and they take the product of that. This value gets paired with that value, take the product of that, and then add everything up, take the sum of everything. It's going to give us the same. So let's put in some sample values, make sure it's working. I predict if I put a 1 in here and a 2 in there, then I should get 12, because 1 times 2 is 2, plus 2 times 5, that's 10, add it together, it's 12. So 1 and 2, 12. There we go. So I'll just put eval here, and this column will be the evaluation column. Then we have our constraints. So we've got first a less than or equal to constraint, and I'll put the direction of the constraint here. Just to remind myself, this is a less than or equal to constraint. The coefficients are 1 and 2, right? 1 and 2 are the coefficients. It's going to be 1 times x plus 2 times y, and that has to be less than or equal to 16. So I'm going to go ahead and add another column. This one is going to be I'm going to call it the right-hand side column. So let's go ahead and evaluate our constraint. It doesn't matter how we lay out our spreadsheets. All we need to do is create some way of evaluating these. We need to have cells that represent the decision variables that Excel can change, and we need to have some place that we evaluate what our objective function is and what our constraints are. You don't actually have to have all these coefficients in the spreadsheet. Excel doesn't necessarily need those. All it needs to be able to do is evaluate what your constraints are, and you're going to tell it somehow what the right-hand side of those constraints are and whether you're trying to minimize or maximize the objective function. But I just find it convenient to lay everything out like this so I can do some product of these coefficients and our decision variables. So we need to make sure that whatever we do to maximize 2x plus 5y, that this cell here is going to stay less than or equal to the right-hand side of 16. We've got another less than or equal to constraint. The coefficients are 5 and 3. And we can actually just start typing coefficients because, right, if you've got a big problem, well, it's going to be the exact same formula here. Actually, excuse me, you got to be a little bit careful. We want to make sure that when we do this, probably if you want to click and drag down, then you're going to want to lock the decision variable cells so that they don't change. But then I can just click and drag or double click there, and then this is going to give me the right sum product to evaluate the function. So that's one of the reasons why you'll see in a second, you might want to, even if you have some greater than or equal to constraints, you might want to change them to less than or equal to constraints so that they're all in the same direction. And we'll see why in just a second. But in this problem, they're given to us as less than constraints, so we don't need to worry about that too much. Let's get to solving this problem. Once you've got Solver set up, you're going to go to the data menu, and you're going to be able to find it here by clicking Solver. But if you don't have that set up, then you're going to have to go to File, and you're going to go to Options, and then Add-ins. The Solver add-in is what we want. And you say Go, because you want to manage that add-in. And we want to make sure that this box is checked, and then we can say OK. So if you didn't have that checked, then the solver wouldn't appear, but once you have that checked, once you're in the data menu, then solver will appear here. So we'll click on solver. And so what's our objective cell? The objective cell is this one right here. We want to maximize it in this case. It's a maximization problem. Which cells do we want to change? We want to change these two. And what are our constraints? Our constraints are that these cells have to be less than or equal to these cells. And so, these cells have to be less than or equal to these cells. So you need to make sure you select which side. The cell reference is the cell that evaluates your constraint, and where it says constraint here is what goes on the right hand side, and you need to choose the sign appropriately. We've got less than or equal to constraints, so you can choose less than or equal to, or greater than or equal to. We'll talk about these in a little bit. Ours are less than or equal to, and that's the reason that you might want to convert everything to less than or equal to cells, because instead of individually adding, oh, I want this to be less than or equal to that, and then I want to add that, and then I can say this one we want to be greater than or equal to the right hand side. Well, it's easier if they're all less than constraints, because then we don't have to add them individually. We can just go, let's delete these. We can just add once and click. Those need to be less than or equal to these. We say OK. And finally, we've got some x and y are greater than or equal to 0. I'm going to go ahead and make unconstrained variables non-negative. That means they are either 0 or positive, non-negative. And I'm going to select a solving method. I want to select Simplex LP. And then we click Solve. And this pops up, solver found a solution, all constraints and optimality conditions are satisfied. You can see that this cell is less than or equal to 16, this cell is less than or equal to 45, and we're able to maximize our objective function value by giving 0 to x and 8 to y. And we say OK. So that is the solution of our first problem. Let's do the second one. Let's go ahead and do this one in a new spreadsheet. So this is the problem we're trying to solve. Minimize 5x plus 7y subject to these constraints. So our decision variables, we have x and y again, but if we had more, we could continue across. And the initial values, I'll make 0 for both of them. Our objective function that we're trying to minimize, our coefficients, we've got a 5 and a 7. It's going to be 5 times x plus 7 times y. And then we want to evaluate that, and that is the sum product of these cells, and we're going to lock the decision variable cells so that we'll be able to click and drag it down later. Then we've got a greater than or equal to constraint. This one has coefficients 1 and 3, and we want to keep that greater than or equal to 6. The next one is a greater than or equal to constraint with coefficients 5 and 2, and that has to be greater than or equal to 10. And finally, we have a y is less than or equal to 4. I'm going to enter it as greater than constraint. I'm going to say negative y is greater than or equal to negative 4. So I'll put a negative 4 over here. 0 is on the x, and a negative 1 is on the y. And then I can click and drag these. Sum product, because those cells were locked, is still correct. I'm going to go to solver, set the objective function cell, which is right there, to a minimum value by changing variable cells, these two, and I'm going to add my constraints. All of them are greater than or equal to constraints, because I was careful to do that. All these cells have to be greater than or equal to these cells. We say OK. Make unconstrained variables non-negative, select the Simplex LP, and hit solve. Alright, gave us a success message. 6 is greater than or equal to 6, 10 is greater than or equal to 10, and negative 1.5 is greater than or equal to negative 4, and apparently this is the value that maximizes the objective function there, subject to those constraints.